資料のチェック、そしたら資料のチェックしたらHello, everybody. Thanks for coming to IPv6 Readiness Measurement BoF and APIPv6 Task Force, today's last session. We have lots of information to be shared by lots of speakers, so I will jump into the session. Usually, Task Force comes do some session, then BoF would followed by. Today we swap the order, and Measurement BoF would the first, then Task Force. And so, Professor Chen, please do open.
Thank you. Good afternoon, everyone. My name is Xianxiong Zhen. I'm from TWNIC, Taiwan. It's my great pleasure and honor to host the IPv6 Readiness BoF meeting. And first of all, I'd like to welcome all of you to participate in this event. And I'd also like to thank all the speakers, including Mazizuya-san from NTT Japan, Fuzisaki-san, okay, and Professor Xin Chang from Thailand, as well as Mr. Ruguyam Tam Tam from Thailand NIC, and I-Chin from TWNIC, Ms. Visna from RIPE NCC, as well as Suchiya-san from Cisco. I also like to give my special thanks to APNIC, especially Miwa, for their help. Without their support, this BoF meeting cannot happen. And for the sake of time, also we have 3 hours, so it's a very long session. So, but for the sake of time, I like to suggest that each presentation will have maybe 10 minutes for presentation. And therefore, we have 2 or 3 minutes for discussion. So, firstly, I'd like to invite the first speaker, Fuzisaki-san from NTT Japan. Welcome.
Okay, good afternoon, everybody. Thank you for introducing me, and I'm Tomohiro Fujisaki from NTT, and also here with the head of the IPv6 Promotion Council Japan. Okay, let me start. Okay, at first slide, I explained the Japan IPv6 status briefly. And about network status in Japan, many fixed line ISPs have started the IPv6 commercial services, not only for the enterprise users, but also for the consumer users. And also, some ISPs began to migrate their IPv4 customers to the IPv4, IPv6 dual stack environment automatically. So the total number of IPv6 users are increasing in Japan. And from the cellular service viewpoint, in Japan, we have 3 major cellular carriers, and 3 of 2 have already started the IPv6 service, but currently that is not the default service, so not so many users are using IPv6 with the cellular phone services. And actually, the network is almost ready, but the content side is not so good situation. The government website, government services began to implement IPv6, but the large content service providers do not support IPv6 yet. This is a brief summary of the IPv6 status in Japan. And here, I'll introduce the measurement of IPv6 in Japan from the following viewpoints. First, core network point, and second, applications, and third, access network, and users, and products, and the government IPv6 service. Okay. And first slide shows the IPv6 allocated prefix in Japan. As you can see, the allocated prefix, announced prefix, and active prefix is smoothly increased. And second measurement is the number of IPv6 enabled transit service provider in Japan. Here is a two graph, and left graph shows the worldwide average, and the right graph shows the Japan average. As you can see, both graphs increase smoothly, and the Japan average is a little the worldwide average. Okay. Oh, sorry. And next, I'll explain the IPv6 penetration rate in the user environment. And here, I'll show you some data of the NTT East and West Internet Access Platform service. That is the reason why we explained this measurement later. I explained later why we measure this service mainly. And for reference, the KDDI service and Tube Telecommunications Network service. Okay. And this is the fixed internet access service in Japan. I'm very sorry, but this graph includes the Japanese characters, but the top red line shows the number of subscribers in the total internet service. And the blue line shows the fiber service, FTTH service. And so, as you can see, almost 70% the FTTH service is of the total internet fixed line service. And in this 70%, the NTT East and West, okay, NTT East and West service share is almost 70%, so they are two NTT service is very high in Japan. Then this table shows the number of penetration rate in Japan. So as you can see, this area shows the number of users and penetration rate of their NTT East and West platform service. And for reference, these two number is here. And as you can see, KDDI already finished to move their users to their stack environment. Okay, and from this table shows the IPv6 traffic to Google servers from the Japan ISP. And as you can see, the KDDI is the top. And this is the percentage of the IPv6 traffic of the total internet traffic. So, okay. Then this is also the traffic graph from this URL. And as you can see, this green line shows the IPv6 percentage to the APNIC servers, and blue line shows the Google servers, and red line shows the Akamai. So as you can see, almost over 10% of traffic is IPv6 in the APNIC case, and Google and Akamai is almost 5 or 6% IPv6. Okay, then next I'll explain about the content side. So this graph shows the IPv6 penetration rate of the web servers. So here, the left graph also shows the worldwide average, and right graph shows the Japanese average. As you can see, the average in Japan is very, very low in the web servers area. And this graph shows IPv6 supported .jp domain servers. And red is the DNS servers, and green line shows the mail server, and blue line shows the web servers. As you can see, the number of web IPv6 increasing. And this table shows the IPv6 service in government service, IPv6 service in the government. And, oh, sorry. And from this URL, you can see these pages, and this is the November 2013, and this is last month. So as you can see, green field shows the services available, and red field shows the services not available. So as you can see, the green field increasing, and this is percentage of the service. And so also this URL shows not only the number of services, but the status of each services. As you can see, the service is working well, and something wrong with the service. So you can check the service status of the government servers. Okay, this is almost last slide, and this graph shows the number of products with IPv6 ready logo in Japan. Recently, not so many products applied to get IPv6 ready logo, but the total number is increasing also in Japan. Okay, this is summary. In Japan, IPv6 internet connectivity has deployed smoothly, but need to tackle to improve the content side. Okay. Thank you for listening. Any questions? Yeah.
As you mentioned in your last slide, so, you said your question is about the content provider. Do you have any strategy or any idea to encourage more Japanese content provider to provide IPv6-enabled services? So what's your strategy or policy?
Can you hear me? Ah, it's okay. So actually, that's and in Japan, for example, at the last journal meeting, we have a session to ask providers why do not implement IPv6. And yeah, actually they say yes, currently the IPv4 is majority and not need to implement IPv6 just now or something like that. So we ask the content providers the reason and to how to enable IPv6. Or, yeah. So that is in the pronunciation.
Okay. Thank you. Other question? Yes.
I'm Dr. Govind, CEO of ICSI, National Internet Exchange, India. I have a question. Japan is a good example of, IPv6 adoption in this Asia-Pacific region. So countries like India where, a lot of government efforts are there, but the telcos and ISPs are very much not motivated towards adopting IPv6. And, the reason being then, cost-benefit analysis, consumers are, because if it is the network is enabled, but the consumer side it is not, or the user side. So what is the way to, motivate them further? How to move, if there are clear applications are not there towards IPv6, apart from just IPv4 exhaustion, numbering and all. So what way, if, because they are still thinking, IPv4 is enough right now, why to bother about IPv6?
Yeah. Mm. So I'm sorry if I misunderstand, but yes, actually, in Japan, implementing the IPv6 to the user or ISP side is mainly conducted by the community, not so many involvement from the government just now. And the main motivation is, of course, IPv4 exhaustion is the main motivation, but
Is there can be any other motivation, because adoption is very, why it is not going further? If you look at the number of IPv4 versus IPv6 adoption numbers, even in the developed world, it is still not growing up. And particularly in the Asia region, when the internet came much later, there is a huge scope for adoption of IPv6. So how to go further? What way it is required? What are the factors? What are the ways to, at the telcos level, ISP level, small enterprises? Because end-to-end, unless everything is IPv6, it is not going to succeed. Even if the one part of the whole network is IPv6.
Yeah.
So if content providers and users have to be in that fashion.
do you have any opinion? So
Can I comment some about the Japanese market?
Yes.
I'm Takeshi Motohashi from Internet Multifield. One of the things we are seeing in the market is about cloud services, because many data center and cloud services needs more IPv4 address, because many users access not from the IPv4. So first of all, the cloud services want to have a lot more IPv4 address. And the other thing, we are seeing Internet of Things era. The future of the internet, we will have much more devices in the market. Actually, even in Japan, there are so many people and companies want to see the future in IoTs, and there are so many. They should need to have much more IP address. So when the marketing accelerating to accelerate market of the Internet of Things, IPv6 is also the good option for them. So currently, so actually you mentioned about that, and yeah, it is okay. Yeah, before V6, anything is okay, but in the near future, there are much more devices or sensors having internet access.
Thank you for answering the
Okay.
question instead of me.
Yeah, the last question.
Can I comment? No,
Yeah,
no
okay.
question. Just,
no question, or just only comment?
Just a comment for
Okay.
Dr. Govinda's question.
Yeah.
I think it's a very interesting question. And I saw how Japan coped with this IPv6 adoption. It didn't come overnight. They worked really, really hard in very structured way, with spending so many years since early 2000. As you know, there is the market leaders, the players and government stakeholders got together and created the working groups, a lot of working groups, multiple groups. Different group was assigned with different tasks. For example, one task was given to work with how to enable IPv6 for CPEs. And another group was assigned how to develop the capacity development. And 4 or 5 different working groups has worked throughout last maybe 10 years. And every month or so, periodically, Ministry of Internal Affairs and Communication, government people, and these industry people from different industry, content providers and service providers, telecom operators, everybody got together in small meeting room and went through all the outstanding issues step by step and come up with the action items and go back to the field and fix those problems and come back next month, discuss about that. If you go to the MIC website, there is the history of their meeting documents. As such, I think Japan has a very interesting case how to cope with the IPv4 address exhaustion and increase the IPv6 adoption through the multi-stakeholder collaboration. Maybe at offline, you may talk with Fujisaki-san and the key people of those working groups and maybe learn from them or share, listen to what they did, could be the first step, and maybe similar approach can be used in India. Thank you.
Thank you. Of course, we have also developed these multiple working groups at the CP level, equipment manufacturers, telcos, ISPs, government sector. It's a national task force and working groups are already made the way the Japanese government has done. And these working groups meet regularly and in collaboration with the industries and other multi-stakeholder groups, education institutions. And yet the adoption process or the migration process is not that fast as we expected earlier, though there are a lot of efforts going on within the country, but adoption level and the migration level is not there. That's
Okay, thank you. Maybe we can have more offline discussion with Fusizaki-san.
Yeah.
Okay, thank you.
Thank you.
Here's some souvenir. Yeah. Thank you very much. Okay. The next speaker is Professor Xin Chang from Thailand. Okay.
So thank you very much, Professor Chan. Hi, good afternoon, everyone. My name is Sin Chai from Thailand. So I would like to just a couple minutes to update the IPv6 status and update in Thailand. So this is the NSC, the work of and come up the IPv6 forum in Thailand. So my talk, is just a short one, right? So the first one to update IPv6 status and what is our next plan and conclusion. Since we are in Asian, right? So we keep monitoring so what our neighbor countries go on. So this is a status. See, Singapore is Singapore is number 1, 38%, and followed with Malaysia, Thailand is number 3, right? Now Indonesia, Vietnam, and Philippines. So this is a big picture of IPv6 in terms of the IPv6 prefix in AS number. We work with the Asian since by the end of last year. Okay, we will be the Asian community. So we host the IPv6 collaboration in Asian just last year, like April, with our neighbor country. So we come up like the most prevalent that they would like to see is the human training. So they're still lacking all the IPv6 skill and technical stuff. That is our conclusion after we have today's workshop. So what is the Thailand action? Okay. Our government just released last year plan for 3 years to run the national IPv6 Thailand master plan. So this year is the 2nd year. So what is the outcome of the 3-year plan? In this plan, okay, it's cover 4 categories, similar to the KPI. So we try to cover the on-off stuff like the IPv6 infrastructure. I'm not sure how to press. IPv6 infrastructure is for 15 KPI, human development, service and support, and the public awareness. So we cover I think every topic that we need to concern to make IPv6 running stability. And we keep monitoring how our country is planning on IPv6. We have allowed 80 IPv6 prefix. Unfortunately, allow just 1/3 that alive. That means that another 2/3, just kept in stock. This is not surprise. We see the big picture. Probably is similar figure. And we also keep our monitoring by using other from Google, IPv6, Cisco Lab, APNIC, something like that. But we also have our own IPv6 monitoring system. It looks like this, right? So these measurements we in our own develop, but the parameter is similar to ASI of the US government. This is a daily result, so we run monitoring once a day. Since when we turn on IPv6, it seems that it's up and down. So we try to make a conclusion for like the monthly report, how is your IPv6 stability or reachability? If like you pass 80% of each month, so we give you the green color. Otherwise, if lower than 10%, we give you the red color. So this one, we can know that IPv6 is in instability condition. So we need to see what's happening. This is our IPv6 status update that hosted by the EGA. EGA is an e-government agency. It's similar to the ISP, but it provides for the government service only. So you can see that for the service hosted by the EGA, DNS, mail, and web, we have the quite high number. Like DNS, it nearly reached 100%. Like for the web, it's allowed 70%. Yeah, but the mail is in a low number. So this one is similar to the ISP that run for the government agency only. But unfortunately, just some the government department use the service from the EGA. So we face other problem that the use outside ISP or public or private ISP. So we come up with figure. Now we monitoring our government department is allowed 360 departments. So you see that the green one is IPv6 number that we found running in that cell, and this is the web. And we give the green color if that department complete the 3 of them here. So it's just only 2%, like in whole figure. And you see that in progress is allowed almost 40%. So this is the trend of the e-government from 3,600 departments across the one that form the EGA. You see that the web service is almost 80 website now, but for the DNS it's still allowed 30, and the mail is still very low. It's lower than 20. So this is our e-government IPv6 service right now. And this is where I am now. I'm working at the UNINET. We have almost 200 Thai universities. You see that the web is still lower than 20. This is very, very disappointing. But for the DNS, it's quite high, like 35 of the 200 university. But you see that it's up and down from time to time. And we also monitoring the private sector. These results come from a top 100 Thai. We analyze from the hit rate, okay? So we filter the top 100 of the hit rate from a Thai web service, and then we go have a look. So what happened here? You see the website, it's just only one website that have the IPv6 service from the Thai private sector. But you see that we found that the quad A in the DNS anyway is around 25%, 25 DNS that already have the quad A record, but they haven't turned on the web service yet. So this is a problem. For some good progress, for the big ministry like the Ministry of Finance, all of them are complete with the IPv6, Ministry of ICT, and certainly Ministry of Science and Technology. So on the big three ministries already complete with IPv6. So what is the next step? So we are working for a large block for IPv6 address. So we expect to see a big jump of the IPv6 prefix next year for the whole e-government. And early of next year, we will launch a second plan for the IPv6. And now we are pushing for DNSSEC. This is we plan for the test drive or the next event. We will do the opposite with IPv6 day. In the IPv6 day, they turn on the IPv6 service, right? But in our Thai Uninet, we've been turned off IPv4 service. So that means that December this year, okay, we will test by turn off IPv4 and then see what happened. And next year, June 6th, we turn off IPv4 for the whole day. And we bring this idea to the government probably next year, sometime in next year. Some good experience for IPv6 user, we found that sometimes it's faster than IPv4. So this one is from October, is in September, okay. From time to time, we try to test, okay. Our colleagues have been notebook and connect to Wi-Fi and test the IPv6 speed. Yes, we experience sometimes it's quite often, okay. It's run faster. And then we go to other tests, it's similar results, okay. So that means that IPv6 service in Thai Uninet, okay, it run faster. We give IPv6 book in Thailand for free. So this is a compliant with the IPv6 3D logo engineering course. Okay, we are going to kick off the TH now next week. Yes, this is the conclusion. Okay, we restoring the internet to level end-to-end, and certainly Thailand is on the way. Okay, thank you very much.
Any question? Professor Xinchang, I have one question. Regarding your monitoring system, is the monitoring result open to public or only for internal use?
Actually, we open to public, but in domestic only.
Here's some souvenir. Xinjiang, just for you. Thank you very much. Thank you. And the next speaker is Mr. Nguyam Tem Dang from VNIC. Please, Mr. Dang.
Hi everybody, I'm Nguyễn Tiến Dũng. I come from VNNIC. My organization in Vietnam manages IP DNS interaction, and so we're responsible to promote IPv6. Today, will give you some update information about IPv6 readiness in Vietnam. As you may know, our national IPv6 master plan had 3 phases. Now we are in the phase 2 to deploy dual stack forming domestic IPv6 networks, provide the IPv6 service for customer to test. Here is some key activity which we had, which we did in 2014. First, we had host Vietnam IPv6 Day 14, even in 6 May, with the topic IPv6 Showcase annually. This conference has more than 300 participants, and if you need more information, you can access to this link. And now, and in 2014, we have turning the national IPv6 master plan. We keep 3 phases and durations, and we add more objects to promote, such as social networks, ccTLD registrars, gTLD domestic registrars, software companies, network equipment providers, and its newspaper. We also have CMP6 certified network program workshop. We have IPv6 training course for community. We also participate in IPv6 renewable program training course in Japan. We boost and issue some Vietnam's standards for IPv6 and so on. One of the most even is in 6 May 2013. Mr. Nam Thang, Deputy Minister of MIC and CEO of 6 top local ISP, launched IPv6 service on the Vietnam IPv6 Day. And now I will talk about the methods and criteria to assess the IPv6 readiness in Vietnam. First, we do surveys, and then we monitor in monitor on the VNNIC networks, includes national DNS, VNIX, Vietnam National Internet Exchange, and then we collect information from the organizations, such as ISPs, enterprise, CP. This survey was done in 2013, and here are the results of the surveys. There are 43 local ISP and CP participate. 3 ISP with full 16 criteria readiness, VNT, TEL, NetNam, and 6 others with 10 per 16 criteria readiness. The remains go very low ready percentage. This graph illustrates IS with IPv6 prefix as allowed. They around 12% with 19 out of 156 IS. This graph illustrates the IPv6 penetrations. Vietnam's had around 0.07%, as measured by Google. And here's the IPv6 connectivity in Vietnam. Vietnam national IPv6 networks includes national DNS, VNS, and ISP network. There are 3 DNS support IPv6, APF.DNS server.vn. There are 10 per 17 ISP have dual stack connection to VNS. One ISP has dual stack leave our VNS, so there is only 10 per 7 ISP. IPv6 traffic via VNX is around 0.55%. Therefore, ISP have international IPv6 connection to SKIH, Akamai, SE, Google, Microsoft, and Yahoo. We have allocated 2 IPv6 blocks, 13.2 and 1 IPv6 block, 14s. So totally we have 20 IPv6 blocks, 32 and 24 IPv6 blocks, so 40s allocated. About Thunder Broker, NetNam, one of the biggest ISP, has over more than 13,000 tunnel having created. They over 19 server, DNS server have support your stack. The proportion of AAS query is around 18%. They over 17 websites have active dual stack, includes social networks, ministries of information and communication sites, includes online shopping, file sharing, online payment website, online shopping. About CPE, they seek local vendors provide IPv6 supported products in the market, include ADNL modem, ONT, exploit, and SmartPack, and also non-yes, mobile 3G, non-yes. There is some positive results in deploying IPv6 in Vietnam, but still a lot of things needs to be done. Here's our next plan in 2015. First, the national IPv6 task force continue to play as leading roles in IPv6 deployment and some on-site inspection to be carried out to ensure the national action work well. We will review phase 2 national IPv6 master plan, ready to implement phase 3. We will increase the promotion to improve public awareness of IPv6, focus on new objects. We will conduct a survey about awareness of IPv6 important forming object. We will set up an IPv6 logo, IPv6 enable program lab. We also hold 2015 annual IPv6 Day in 6 May IPv6 LTE conference. We will hold IPv6 training course for community. Thank you. And any question?
Any question? No? Thank you very much. Thank you. The next speaker is Ai-Chin from TWNIC. Please, Ai-Chin.
Good afternoon, ladies and gentlemen. My name is Ai-Chin Lu from TWNIC. Today, I would like to talk about the status of IPv6 readiness measurement in Taiwan. And I also want to let you know what we did and how we get the results. Regarding the IPv6 readiness measurement, we classify different measurement criteria from different organizations or ccTLDs. And we have 3 common measurement criteria. Now let me update the TWNIC, the Taiwan's, these 3 common criteria. The first criteria is IPv6 allocation and the BGP advertisement. The data is from RepNCC. Yeah, I think from these lines we can see that has level out, but the percentage is between 25% to 33%. The next criteria is user availability. Yeah, you can see from this line, we can see that has climbed steadily last February to this, last August to this February. But the percentage of user availability is still lower, and just 0.94%. The third criteria is service availability, which is including the web, DNS, and the email. I think the 3 curves, I think, has the same shape. So in the beginning of this year, just have a fluctuation, but they still remain stable. So these 3 is Taiwan's 3 common criteria. This time in here, TWNIC will propose another 2 measurement criteria. The first one is access router gateway availability in network phase. The other one is home gateway availability in user's phase. Yeah, from the international internet operation diagram, yeah, from here I think you can easily know why we will propose these 2 measurement criteria. If you are, for this part, we divided 3 users phase, network phase, and service phase. If you are the IPv6 end user, you want to have IPv6 internet access, you can apply the ISP wired or wireless ADSL cable, FTTX, or Wi-Fi, or you can through the cell phone or smartphone use the 3G or 4G service. Then you can easily to connect visit the website, or you can use the DNS email service. So we have the 2 measurement criteria for these 2 parts. Yeah, from the internet operation diagram, so we have the structure of IPv6 readiness. Yeah, for the user phase, we have a user availability. For the home gateway availability. For the network phase, we have access router gateway availability and the IPv6 allocation and the BGP advertisement. In the service phase, we have a service availability. Yeah, I think the structure of IPv6 readiness is mapping to the internet operation diagram. So now let me talk about this IPv6 access router gateway availability. Yeah, in TWNIC, when we discuss these issues, I think the initial idea is very simple. We are very naive to think about if suppose the ISP access service device are ready for the IPv6, then the utilization of IPv6 will be happen at any moment. I think this is our motivation for this availability. So we conduct a survey by questionnaire. We check whether ISP internet access service device is IPv6 capable. Then we found this in the beginning of this year, so we do the survey, and the sample is from TWNIC 61 IP registrars. That means 61 ISPs. And the response rate is very high, it's 98%. So we got the survey results. Among 60 ISPs, 48 ISPs provide wide and wireless internet access service. And within 48 ISPs, 44% and 29% ISPs provide FTTX and cable access service respectively, which are the top two. Then we find in cable FTTX, ADSL, Wi-Fi, 3G, 4G are the 6 major access services in Taiwan. And we know each access service corresponds to different access device. This is our IPv6 access router gateway availability, the result. You can see the cable is 21%. Yeah, if you refer to the right-hand side, they have a cable access service is 40 ISPs. So just the 3 ISPs device are IPv6 capable. So ADSL is 57%. FTTX, I think, is very high, is 76%. Yeah, because 21 ISPs have 16 ISPs device are IPv6 capable. So Wi-Fi is 75%, 3G is 60%, and 4G is 100%, because in Taiwan they have 5 ISP provide this service. So the device are IPv6 capable. Next time we talking about the IPv6 home gateway availability. Yeah, I think the HiNet is the largest ISP in Taiwan and already provides FTTX access service with IPv6. So the first thing we just think about, we suppose if 3.2 million HiNet FTTX users, home gateways are all in IPv6 capable, then the user availability will largely increase. So this is our motivation. So we conduct a survey by reviewing home gateway spec and from 50 major vendors, which are over 50% market share. So we got this result. 8 vendors, home gateway support IPv6. 7 vendors, home gateway not support IPv6. So in here, we have 5 vendors, home gateway, support IPv6, the home gateway with the IPv6 PPP OE, this function. So the point-to-point protocol over Ethernet, this function, I think everybody will think a little bit strange why we will focus this function, because this function is mapping to FTTX device broadband race, which is HiNet, use this access device. So it's special to focus this function. So now let me give you a conclusion. Regarding IPv6 promotion nowadays, to provide IPv6 Internet Access Service is the most concern. For providing Internet Access Service, IPv6 capable access router gateway is a must. I think this home gateway is one of the critical devices for home users to access IPv6 network. And I noticed the tool availability is related to the vendor. So we think how to get more accurate IPv6 cable access device data. We consider to cooperate with ISP vendors or manufacturing to build a mechanism of data collection. Yeah, this is my presentation. Thank you.
Any question or comment? No? Thank you very much, Ai-Jin. The next speaker is Ms. Visna from RIPE NCC, please.
Hi everyone. I used to be IPv6 goddess at RIPE NCC. That was my unofficial job title. I was actually a trainer. And now I'm a community builder for measurements tools. So my goal today is to share with you the results and the data that RIPE NCC has, and to invite you to use our tools and our measurements for the tracking of the IPv6 deployment in your country and in your region. So RIPE NCC is a regional internet registry, and as such, our main goal is, or role is to give out IPv6 addresses. But in order to find out how successful our members are in deploying IPv6, we also had to educate them on how to use IPv6 and to track their progress. So a few years ago, we came up with this sort of measurement, but it's actually just the indication of the readiness called IPv6 ripeness. So I'm going to talk briefly about that. Then I'm going to show you some other tools, and I saw that some of you are actually using the one, it seems quite popular, IPv6 AS numbers, and then show you the RIPEstat, which is our other tool for showing the statistics. And second half of my talk will be focused on the RIPE Atlas. I already talked a lot about it in this conference, so it will be really brief. So IPv6 ripeness is a kind of tongue-in-cheek name for how ripe are the LIRs, the members of the RIPE NCC, with their IPv6 deployment as far as we could see of the services that RIPE NCC provides to them. So what we looked into is if they have an allocation, did they set up reverse DNS? Did they register the route object in the routing registry? And is their announcement visible in RIS, which is our routing information service where we collect BGP information? So once we collected this data, we would present it in the combination of the country-specific chart, which shows the percentage of the members that either have one or more stars. We also generate daily this table where you can see all the countries in the world, because some of our members actually offer services in the outside of the RIPE NCC service region, so you can actually find Japan here too. And we would go to the training courses and actually tell to the participants, congratulations, you have 4 stars IPv6 ripeness. We also published this list per country, and we only published the names of the companies that actually have 4 stars. So it's not like naming and shaming, it's naming and celebrating the ones who did their homework. And to answer the question of the gentleman from India about what can you do to encourage people to deploy IPv6 as content providers or as anybody else, the secret is free t-shirt. So we made a T-shirt with IPv6 Act Now, and every organization that reached 4 stars and they would show up on the training course, we would actually prepare in advance and bring all those T-shirts to them, and they were really, really happy, and all the other people would, in the coffee break, go and configure their routers and say, I also have 4 stars, and then we would have to ship it to them because, of course, we were not prepared. So it's really fast to get to these 4 stars, and we've been following this kind of methodology for quite some time now, and last week we published an article showing the IPv6 ripeness development over time. And you can see the 2 spikes over there. So this was when IANA ran out of v4 and everybody kind of rushed and got v6. And they actually did something with it. So they went from these 1 star, which is just having an allocation, to actually doing some more things and announcing it in BGP, which is like the dark green. And then it kind of slowed down, and then RIPE-NCC ran out of v4, and all of our members again rushed and said, oh yeah, can we have some v6? So there was a big spike. And then we had a policy which said you can get the last remaining bit of v4 when you are a member of the RIPE-NCC, only if you also ask for v6. So yeah, everybody had to get IPv6 allocation, so there was a lot of increase. And then we looked into how are they doing historically. So we looked into like 6 years back, and in these 3 diagrams you can see the group of the LIRs that received their IPv6, now I have to check my papers for these time periods. So this is in 2008, 9 and 10, and then 2011, 2012, and this is 13 and 14. So you can see the older allocation is, the more time they had to actually reach the 4 stars. And then these other people, they took it a bit slower, so there is more of these LIRs that have only allocation and they're doing nothing with it. And then the last group, which was getting their IPv6 in the last 2 years, they actually are just sitting on it, and they only got it because they wanted IPv6. They wanted IPv4. So some of them actually moved forward and started announcing it in BGP, but not too many. So there is a bit of bias here because they didn't have enough time. And in the article, you can also see the other way of looking at this, which is giving it a little bit more balance. But in general, the older organizations are more further in deploying v6. And then some people were saying, yeah, but the fact that somebody has 4 stars ripeness doesn't really mean they're doing anything with v6. And yeah, that T-shirt, that's not really fair that they are having that T-shirt. So can't you measure some real deployment? And that's quite hard. So we tried it, and we called it the 5th star. It is still like a prototype measurement, and we separated the members of the RIPE-NCC into access providers and content providers, and then we do some specific measurements for both of those groups. So we started doing this in 2012, and the criteria at that time was that they will get 5th star if they have more than 1% of their let's say, users using IPv6. And then we moved to 2% and then 4%, and now the threshold is 8%. So it's actually not enough to just have the same percentage of users as few years ago. The deployment rate should be growing in order to get this 5th star. So again, we published the list per country of the organizations that have 5 stars. It's much smaller list, and they're still not getting a T-shirt, so there is still some space for the growth, for the promotion of v6 by the RIPE-NCC. So moving on, you already saw this graph from a few more presenters. So a very popular service apparently, v6 AS numbers. So here you can plot multiple countries and compare the data between the countries and over time. So we are basing this on the routing information service that I already mentioned, so our collection of the BGP data. Soon we are going to move this visual representation into something like this, which is another service of the RIPE NCC called RIPE-STAT. So you can currently also use RIPE-STAT, but only comparing the number of prefixes up to 4 countries. But additional features that you can actually, on the same graph, compare V4 and AS numbers per country. And also it gives you overview over time. So this is to give another answer, how can you encourage the V6 deployment? Well, we saw, at least in Europe, I'm not sure if Asian Pacific region is different, but I would not think so, because it's quite in human nature. The people like to compete. So when you go to your government and say, look where we are on this graph compared to our neighbors, then they go and say, oh no, we have to improve. And in our plan for the next year, we are going to overcome those neighbors and we'll be on the top. So this is kind of a good tool to, well, let's say manipulate public opinion or talk to the ministers of the government. And it's quite a nice and colorful thing that you can tweet about and put in your report. So I invite you to use it. Moving on to some actual measurements. Now, this is not about the deployment percentages and so on. These are the tools that are actually useful for the operators who decided already to go to V6. And so these are the tools that help them to test their deployment and to see the reachability of their networks from across the globe. So very brief introduction to RIPE Atlas. RIPE Atlas is a measurement network that is collecting the data from hardware probes that look like this. So it's a little hardware device that you plug in into your network, and there is currently about 8,000 of them spread all around the globe, hosted by volunteers, either in their homes or in their data centers and in their offices. So we collect data both from the end users and from the core network. And RIPE NCC is doing the measurements from all of these devices towards root name servers, both V4 and V6. There is more than 2,000 of them that are V6 capable. They're sitting in the V6 capable networks. And the users who are hosting these probes, they also get the opportunity to harness the power of all the other probes to do the measurements for them. So in that way, you can do the ping, the trace route, and the DNS lookups from thousands of vantage points towards your server and see what is the difference between V4 reachability and V6 reachability, for example. How is the DNS responding over V6, and so on. And in the next few slides, I'm just listing the research done by either RIPE NCC or the external researchers. So this was the tool developed by us for specifically RIPE NCC members at the time of the V6 day. So at that time, everybody wanted to, show off and deploy V6 quickly, and then RIPE Atlas was there to show them the reachability of the network. So we created this pretty visualization where it would show from 1,000 V6 enabled probes what is the path, which AS numbers are those packets traversing towards their target. And then they could also click on each point and see which AS number that is, and so on. So there were two pictures, one of the paths that actually were completed, and the other one where there was some problem and that they couldn't complete. So they could actually contact those peers, operators, and ask them like what the problem is and try to fix it and so on. So some people used this and created some use cases where there were showcases how they optimize their routing based on the RIPE Atlas data. And then there is another research here about V6 DNS. So once you enable DNS over IPv6, what will be the success rate? So Stefan Botsmeyer from the French ccTLD was looking into the percentages of the probes that can resolve V6 only or mixed DNS names. And of course, this is only the kind of representation of all the hosts on the internet, but it's fairly accurate one. So there are some more researchers from the universities that are using RIPE Atlas. So if you're curious, you can download their results. They presented it at 2 RIPE meetings ago. There is a lot of research on the filtering going on. So either prefix size filtering or DNS filtering, or even more specific, how are the extension headers being able to propagate through the IPv6 networks. I'm going through this very quickly so that there is more time for questions. The path MTU problems are also kind of famous for reasons why people have trouble with IPv6, so RIPE Atlas can help researching that too. And there is much more information on the Atlas website. If you would like to take part, please come talk to me later on, and for the next 2 days I will be also around here. If you are a researcher or if you are a task force which wants to track the deployment of V6 and you need some more data, RIPE Atlas data is available. The previous ones, the RIPE stat and the RIS data is also available, so get in touch and we can see how we can cooperate. If you want to do your own measurements, we are cooperating with APNIC, and they are also bringing these probes to their training courses. They are trying to increase the number of RIPE Atlas probes in Asia and Pacific region. So you can either talk to them, you can talk directly to the RIPE NCC, and there are several ambassadors, the people who are helping to distribute these probes in different countries in their local community, and you can find the list of those ambassadors also on the RIPE Atlas website. If you have some money to spare and you like this project, you can become a sponsor of RIPE Atlas, and then you can receive a lot of credits for your own measurements, or you can receive some of these probes to give to your friends and to deploy in your network. If you want to use the software, it's all on GitHub. So thank you for your attention, and if there are any questions, I'm here.
It is a very interesting research. So, any question? Any other question? I have one question. Do you have any data to support your software? It's about maybe the correctness or the coverages. Yeah.
Can you repeat the question?
Do you have any data, empirical data? Yeah.
Data
yeah.
from RIPE Atlas?
Yeah.
All the data from all the measurements is completely available. So you can just download the results of all the measurements and then compare it with our analysis, let's say. So, for example, this one, they have done their own analysis on this, and they have published the methodology and so on, so you can repeat those tests yourself. So the RIPE Atlas platform is completely public and open, and all the data is available. It's a little bit difficult to get to because it's quite complex, and there are APIs, and you have to program it and so on. So for the regular users, we have the visualizations that we provide, and for the power users, they can get to all the data using the API data interface.
Any other question? Thank you very much. Yeah. The last presentation will be presented by Tsushi Yasan from Cisco. Please.
Start. Okay, my name is Shishio Tsuchiya, consulting system engineer of Cisco Systems Japan. Today, I'd like to introduce Cisco IPv6 deployment statistics website. This slide explains IPv6 adoption lifecycle, what people should do when they try to use IPv6 in their network. At first, they have to get IPv6 prefix from RIR, and after that, advertise these prefix on their network and make contents which is IPv6 enabled. After that, ISP have to provide IPv6 their access network, and the end user must have IPv6 enabled equipment. All of conditions are prepared, the traffic will be growth. This is our 6lab cisco.com stat. If you are interested in, please click URL. If you put the cursor on the country, then you can show the IPv6 deployment percent and relative index. This is Belgium, the small country over Europe, but they are most developed IPv6 deployment country in worldwide. So their deployment percentage is 48.95%, and the relative index is 10. And you can also select region by country, select a country by region. You are in the Japan. Japan is a very simple, but you can also East Asia, and you can show the, Japan's IPv6 deployment data, and you can check all over country in East Asia. We can show detailed information of each of categories. This is IPv6 prefix. Routable prefix, data from root view project, allocated prefix from whois database of RIR, arrive prefix, check reachability from APNIC lab and Eric Bink site. And we can check transit AS. Transit AS, IPv6 transit AS means an AS that is transit on both IPv6 and IPv4. IPv6 enabled transit AS, an AS that is transit on IPv4 network, but has an IPv6 prefix. And we can check our web contents. Alex rank website by page view and unique user per countries. We check quad-air request to the DNS server for the top 500 user domain name. And in test means test domain such as www6, www.IPv6 cisco.com, name working in the IPv6. And failing quad-air record exists, but website not working in IPv6. Others not IPv6 enabled website. This is web contents. And we can check users. we can check users from Google and APRICOT Lab measurement in the user IPv6 adoption. I think this is a little bit old slide, but yeah, we can check these source. But APRICOT Lab is currently this source is not working, so we have to modify this script, but not yet. So our user data, APRICOT Lab is indicator 0%. We have to modify our script. But you can check IPv6 adoption by the Google search. And this is some option. This is number of IPv6, estimate number of IPv6 user individually. And right click, left click. And we have historical data for worldwide chart and for each of country chart. You can select country by name. Historical data. Yeah, and we can check BGPS, compared IPv4 and IPv6 areas individually. Okay, and we have some options, some tools. This is projection of IPv6 user in future. And we have a widget and Twitter account and percent of IPv6 visitor to this site. This summary, IPv6 stats provide IPv6 adoption of each of country graphically. The result data will be hint of IPv6 deployment plan over future for you. For example, Malaysia IPv6 user was increased from 1% to the 6% within the 2040. Telecom Malaysia joined World IPv6 launch, and their IPv6 statistics reach about 30% now. And Greece IPv6 user was increased from 1% to the 7% within the 2040. GRTN is joined World IPv6 26.17%, and Greece student network 7.22%. And Belgium IPv6 user dramatically increased from 4% to the 30% within the 2040. Belcom and Telenet is two big access provider joined the IPv6 launch since February or March 2040. This is content. Peru's IPv6 continuously increased from 2030 to the 2040. It is 4% to the 11%. IPv6 content site number increased from 33 to the 51. And from our historical data, Telefonica decided Peru as the first country for IPv6 deployment, and Telefonica also started to provide IPv6 Chile's Republic. And their IPv6 contents already reach 81 contents. So I think the Chile will be increase IPv6 adoption. And Japan is very high ratio IPv6 prefix and BGP transit AS, but contents keeping around 36 to the 38. Contents deployment status is about 24.51%. As a result, relative index is 4.8. For example, Malaysia is 5.3, Singapore is 4.9. So unfortunately, Japan is not the best developed IPv6 deployment country in the Asia. Yeah, this is source reference. Okay, my presentation is ended. Thank you for your attention.
Any question? Yes.
Okay, Malky from BPIX. A simple question just came in my mind. How do we define an a user is an IPv6 user? And it means IPv6 enabled or really using IPv6 for the life. And even for the content, so I would like to know if we have some data to show what the IPv6 enabled users are doing through IPv6. Are these IPv6 enabled contents really delivered to the IPv6 users through the IPv6?
So question is how to count IPv6 user. So we just checking Google research data and the APNIC lab. So Google research data checking which client which protocol stack preferred. So actually, I think user data is actually data.
Excuse me, Jeff Houston, APNIC.
Yeah,
Do you mind?
give some comment?
Do you mind if I correct that?
Yes, you are correct.
So what 6 Labs actually do is they scrape the data that we generate in APNIC that talks about users. Now, the way we get user data about users is we use Google's online advertising network predominantly, and we send out ads. Those ads go everywhere. We get about 1 million unique visitors every day. Inside that ad is a very small piece of script. And what that script does is it has a unique URL, no caching. In fact, it has 3. v6 only, dual stack, v4. And those URLs refer to our servers that we run. So you might get this ad. You don't even need to click on it. And your browser will try and fetch 3 things: v6, dual stack, v4. Most of the time you get the v4 one and we see you fetching it because you get it from our servers, so this is normal. Sometimes you will get the v6 only one. That's really good. You're running v6, the DNS works, all the infrastructure works, the transit paths work. You're a v6 user. We also give you dual stack to look at, given the choice, v4, v6, which do you prefer? Because we've noticed that a number of systems, and most recently Macintosh's Mac OS X, when it's dual stack, it doesn't do v6 all the time anyway. It's actually a random roll of the dice, whether it does v6 or v4. Interesting. So from that, because we do a lot of ads, a lot, we can do a statistical sampling technique that allows us to estimate, given the number of users in any particular country, and the ITUT publish that data, we look at the percentage of samples we get over an extended period. Typically the data that Cisco are scraping is 30-day averages. The percentage of folk that we see that do v6, we apply to the ITU data of the number of users in that country. Japan, 66 million users, I forget. That's how we get to 34%, which is about 20 million users. So the way this data works is it's a combination of sampling and estimation. It'd be really good if we could sample people and they'd put their hands up. Too many people, too difficult. This method is about the best method we can find that actually gives you a decent picture. Okay? Thank you.
Thank you very much.
Any other question? Okay, thank you very much. Thank you.
Thank you for your attention.
I'd like to thank all the speakers and end this section. Now I'd like to pass the mic to Miwa. Thank you very much.
Thank you for all the speakers for the IPv6 Readiness Measurement BoF. Now we move on to the APIPv6 Task Force. APIPv6 Task Force and IPv6 Readiness Measurement BoF has been collaborating since 2013. Once TWNIC folks established this measurement BoF, we decided to work together because the BoF is led by TWNIC colleagues and its focus is sharing all sort of IPv6 readiness measurement data, as you saw. And Task Force focus is now on sharing the anecdotal evidence and stories of IPv6 deployment. In that way, we can avoid the reinventing the wheel. So today we have the 7 speakers, Vesna from RIPE, and Sunny from Telstra Australia, Nakagawa-san from Telstra, Nakagawa-san from, JPNE, and Motohashi-san from Multifeed, and Internet Multifeed, and Mawatari-san from JPIX, Kawashima-san from NEC, and Professor Mayan from BUPT and BII. So let's have the first speaker. Vesna, please.
Hi, it's me again. So this is going to be a bit more informal because there aren't any real numbers involved. So the first story I wanted to say is about collecting the funny data and the sentiment analysis, which is quite popular in data visualization nowadays. So we looked into the number of times that people mentioned IPv6 on Twitter and compared that with the number of times that they mentioned IPv4, and then made the visualization of those mentions, and you can see them around the globe. The actual link is over there, it's on RIPE Labs, and that we tracked over a month. So there were some interesting kind of bursts of activity around the globe, and people all of a sudden, for a very short time, were talking very much about IPv6 in Peru, or where in Indonesia they were talking about v4. And then we were wondering, like, well, why is this? So we are actually now expecting the feedback from the back of the community to us saying, oh yeah, there was this task force meeting or something happening on that day. So we don't know why that is, but we thought it would be an interesting thing to take a look at. Then a bit more concrete is that we deployed over the last 2 years at the RIPE NCC about 100 RIPE Atlas anchors. So I already mentioned RIPE Atlas. It's a network of almost 10,000 small hardware probes distributed around the globe. And 2 years ago, we started deploying larger servers, which are hosted by the operators. And so they buy the equipment, they bring it to their data center, and then the RIPE NCC engineers help them to install that box. One of the requirements is to have IPv6. So all of them say, yeah, sure, we have IPv6, and then we start working with them, and they get into so much trouble, and so we recorded all those cases and summarized them in the presentation that my colleagues gave at the RIPE meeting. So you can take a look at their slides, and basically the lessons learned from talking to those engineers over and over again is that IPv6 still has a lot of bugs in the configuration software. That's one thing. The other thing is that there is a lot of care that has to be taken when configuring your network using IPv6, because people are not used to it, and there are all kinds of intricacies involved, and you just have to be careful, for example, on the which prefix are you using, what kind of addressing scheme you're using, do it consistently, and so on. So there are concrete details in these slides, and it might be useful for you to take a look at that, especially if you are planning the V6 deployment, and learn from other people's mistakes, because these engineers were very experienced and they all thought they have the V6 which is working, and then they had to be helped a lot in actually installing it. So the firewall rules had to be changed, and all kinds of configurations had to be fixed. And finally, I already saw that the deployment stories from Belgium were covered by the previous speaker from Cisco, so there isn't much more to say. This is a really nice success story, and from our contact with them, what we realized is like what were the main drivers of this success is that it took a long time. It took 3 years. It took the commitment of 3 largest providers in the country, and very important thing was the strong task force. So they were actually talking to each other, they were meeting regularly, and the task force was important for them as a forum where they could exchange the experiences, exchange the information, and also for the encouragement. So to talk to the fellow engineers and to feel good about how far they got. So I'm happy that you also have a task force that helps you in this area. So the next stories is from Norway. Again, the similar thing, the large ISP, and another element which kind of keeps on coming back is that it's important that the organization has actually control over the customer equipment. So they can choose the equipment that does IPv6, and then the rest is smooth. So if you have a choice, go that route. And I don't know why I put Latvia on those slides, but what I meant is Czech Republic. And they also have a good percentage currently, about 10% of their users, whatever the definition is, as we heard. And that is actually based on the 2 large DSL providers that have equipment that does V6. So then the users appear to use V6 in all the statistics that we are looking at. So a few more stories. Again, task force, very important. There was one meeting of the task force in Saudi Arabia where RIPE-NCC also took part, gave some presentations, and this was in conjunction with something that we also help with, and that is road shows. So it's very important to provide education to the network operators. The road shows, so-called road shows, are the 3-day hands-on course where people learn how to configure the routers, learn the intricacies of the IPv6, and also can talk to others who are in the same situation. The RIPE-NCC is providing the training courses, and among them it is also IPv6. So after every calendar year, we publish results of the surveys that we do after every course. And so what we have learned from these surveys is that people are really grateful for these courses. IPv6 is the most popular course, and it still has the highest demand. So however many we can offer, people always want more. So currently, RIPE-NCC is offering a basic IPv6 course of 1 day, and the advanced course, which is 2 days, with the hands-on lab. We also have 2 webinar topics regarding IPv6 and 2 e-learning videos. And we are constantly adding more content that is IPv6 related. We also have some tools for our members where they can use the web tools to view their IPv6 space and to manage their database objects. And finally, I already covered this in my previous talk. So IPv6 ripeness, following the readiness of the members of the RIPE-NCC, it encourages people to see their name listed as I have achieved this, and it also helps us to see how are we doing with promoting V6, our members deploying it, and so on. Thank you. Any questions?
Any questions from the floor? Right, I have a question, Vesna. Do you have any observation of IPv6 deployment in mobile networks in Europe?
Only anecdotal, and also because it's kind of close to my heart. So Slovenia, which used to be part of Yugoslavia, has actually a mobile operator that is offering V6 to their users. And it's a nice presentation that I saw several times by Jan George, and yeah, it's working. They put a lot of effort into it. They offer it to their clients, and it is accessible on the most unreachable parts of the tops of the mountains and so on, because he likes to go there and to set up antennas there. So,
how about the general interest and trend towards the IPv6 deployment in mobile networks from other mobile network operators in the European region and Middle East too?
yeah, actually, I don't have data about that, so I will have to get back to you on that later.
Thank you. Right, thank you, Vesna. Right, our next speaker is Sunny Young, so from Telstra, Australia, and his topic is related to my question to Vesna, the mobile IPv6 network in 2015.
Good afternoon, everyone. Great. So for anyone who doesn't know me, my name is Sunny Young. I'm from Telstra, Australia. I'm one of the architects in the mobile space, working on deployment in Australia at the moment for mobile wireless. And we've been trying to deploy IPv6 for the past 4 years. We've been testing very thoroughly. We know that there are a lot of other carriers around the world who have deployed IPv6 to consumers already, and are doing it using one of these methods. Dual stack, single stack, or hybrid. Dual stack, as I've talked before in a tutorial yesterday, doesn't really solve all the problems. But if you really want to go all the way to single stack, which some carriers have, there are also issues that are seen. And if you want to review these are available in the slides from my tutorial yesterday. The one I want to recommend to people is this hybrid method, which is to do an AT64 and a DNS heuristic discovery before 64x for their mobile environment. And this is one that really seems to be working very, very well at the moment and seems to be deployed in quite a number of places. And we've seen that deployed, I believe, in Europe in one of the mobile operators. We've been testing very thoroughly through all 3 of these, and we think that the hybrid solution to support both dual stack and single stack simultaneously probably is the best way forward in the short to medium term. I'll just go back one slide. We're seeing some consumer networks with V6 deployed at the moment. So what I'm going to go through today isn't statistics, isn't measurements, it's actually issues that we've identified so far that I want to share with the community, and things that we're seeing that may be coming up very, very soon that we'll help with. First big one is international roaming. We think international roaming is going to be stuck on IPv4 for some time because there's just too many unknowns. The biggest problem with international roaming is that when you start enabling IPv6 with dual stack and your customer goes to a country that doesn't have the most latest revision of 3GPP installed in their core, they're going to get black holed. And until that problem is resolved, if you put dual stack onto your users, it's just not going to work. So until we start resolving this problem and getting some carriers to move on to newer revisions of 3GPP, we're going to be stuck on v4 for international roaming. The next biggest problem is voice over LTE over IPv6. Voice over LTE is voice over data. It's voice over IP. So data doesn't come cheap when you're doing international roaming across IXs. So it raises all sorts of questions about how to actually put it all together. And no one has all the answers to that yet. So given that situation, we'd like to work with carriers around the world to figure out how we can actually get this going. Because if we want a truly native IPv6 world, then we really need to think about voice over LTE IPv6. The third one is a relative unknown, tethering. Tethering is when you connect your iPad, for example, to your mobile handset, which connects to the internet. So you're using your handset as a modem. What happens today? Well, you have IPv4 today in your handset. So your handset is actually doing a NAT4.4 translation, correct? Well, we don't have NAT6.6, and we don't want NAT6.6. So how are we going to allocate an IPv6 address to a tethered device? And the only way we can think of is DHCP prefix delegation, which requires 3GPP release 10. And not all vendors are using release 10. And it's pretty optional as well. There are other methods, but realistically, carriers need to collectively push for a resolution to this because we want to allocate IPv6 addresses to our users on a tethered device. So we need a DHCP prefix delegation solution and release it to evolve packet core solution. Now, the other thing is, how big of a prefix should we actually allocate? And people are saying a /56, because if you allocate a /56 to a handset, then you've got 16 bytes? 16 bytes to your tethered devices. Is that too many? Could be. I mean, are we expecting 200 odd devices to connect to your handset? I don't know. So I'm thinking, well, maybe it should be a /60. That gives you 16 devices. I mean, how many smart devices would you really have? Obviously, with the advance of IoT and smart wearable devices, that may change, but I think that's a debate that needs to be brought forward. What size should that DHCP prefix delegation really be set to? We need to continue pushing 464XLAT. It's so important because we need to do a stateless translation on the device if we're to go ahead with single stack deployments in the future. Because we just can't test all the applications out there. Even though there's been a lot of presentations today about applications needing to start supporting IPv6, it's both. It's both the handset and the application and the servers. So we need to continue pushing 464XLAT support because, well, I can't test 1 million applications from a carrier perspective. I can't test 1 million applications. It's impossible. So we're reliant on the community and app developers to do that, and also on handset manufacturers to support 464XLAT in the long run. So I'm asking you, if there's any carriers in the room, to take that back. Take that message back and talk to your device vendors. We really need 464XLAT. And if you're an application developer, I urge you today, please start writing for IPv6 or make your applications protocol agnostic. If you haven't done so already and deployed dual stack, we need a roadmap transition to single stack because you're just going to cause problems for yourself in the long term if you don't have that transition method down pat in a future roadmap. So that's something to consider because we've had that discussion internally in Telstra as well. And it just increases your costs if you don't have that long-term plan. For CDN providers, I offer you this. Please turn on your IPv6 support if you're a CDN provider. The more localized the access point is with v6 support, the quicker it is, the round trip time it is for our customers. So if you have a CDN that's very close to your customers, just get IPv6 enabled today, because if you've got major content access, and they can be accessed by V6 and your portal doesn't have V6 configured, then it doesn't really work. And I've got to waste money doing a translation for you. The last one's one of the more important ones, is ALGs. NAT4.4, you use ALGs today, and inevitably when you go to NAT6.4, you need ALGs as well. So talk to your vendors for your CGNAT. Everyone, I know a lot of people don't like that word, it's a nasty word, but you have to use a CGNAT in mobile environments, but you need ALGs as well, and not all vendors are the same. So check. What ALGs are you using for NAT4.4 today? What's the majority protocol that your customers are using? And when you're going to NAT6.4, for the vendor you select, do they support the same ALGs or equivalent as your existing NAT4.4 ALGs? And that's one of those issues that we've been seeing as well. With all that being said, that's my presentation. Thank you very much. If you've got any questions.
Any questions or comment? Please state your name and organization.
Hello, Kaveh Ranjbar, RIPE NCC. It's not really a question, it's an answer to the question Miwa had for the previous presentation, but somehow related also to this presentation. Thanks for all the information. Just about the mobile deployment in Europe, I picked up 3 countries to give you some stats. In Belgium was the first country in the world to try V6 deployment in reality. And they did the test in 2010, but VU, which is the largest ISP and also a big mobile operator there, started services in April 2013, and they provide services. Also Telenet, which is mainly an ISP but also does mobile, they are fully V6 capable, and that brought V6 usage in the country by 30%. Germany, Deutsche Telekom recently announced that IPv6 will be enabled in second quarter of this year in all of their mobile network in Germany. And in Poland, they had a very successful deployment, which was done September last year. And they had actually the XLAT issues and all of that. And it seems the only handset that they officially support is Sony Xperia Z1, which it seems supports also 464 XLAT and 64 prefix sharing. So just for your information.
Thank you very much for that information. I'll offer one thing here that I'm very interested from RIPE as well. France Orange. I'd love to see the statistics of them, because they have a full deployment. And there are actually more handsets that support 464 XLAT today. That's been out there. What we're seeing is anything that has Android 4.4.4 and above is actually very, very good. So that's my recommendation to all the carriers, is to start using something like that.
Any question or comment? Thank you. I think it's a quite interesting idea, because IPv6 and mobile network deployment is happening really, really rapidly. And we have a small windows of opportunity to reach out the telecom operators and mobile network operators. And some information and knowledge and information are accumulated in European region. And people like Sunny is collecting some hands-on information. Maybe we should think about some way to share this kind of information, be ready to be referred by other operators. They even haven't thought about deploying IPv6 in mobile networks, or maybe start doing and facing the same problems those operators already faced and came up with some solutions. In that way, we can avoid some reinventing wheel.
Yes, so one more comment. At the RIPE NCC, we have since recently a new position, and a colleague of mine, Natalie Treneman, is IPv6 program manager. She is, on one hand, maintaining our training course material with IPv6, and on the other hand, she's reaching out to the IPv6, well, to the operators, so both mobile operators, other ISPs. She's collecting these stories and helping them out with their deployment, also with like visiting them personally and talking with them, taking part in all the task forces. So if you want to get in touch with her, you can find her details on the RAP NCC website, and she will be more than willing to cooperate with you and with you, Miva, and to kind of exchange experiences between these two regions.
All right, thanks, Vesna. Yeah, I'll follow it up then. One last thing, Sunny, or maybe to the floor. Sunny mentioned about the challenges of the deploying IPv6 in mobile network, and one of them is tethering. The prefix, which prefix, /60, or how many actual addresses should be given for the devices for connected to tethered network? Does anyone in this room have any comment or some anecdotal stories on that point? Nope. All right, that's okay. Thank you very much, Sunny.
Thank you.
So next speakers are from Japan. We have 4 speakers from Japan, and Nakagawa-san from the JPNE would introduce those 4 speakers. Thank you.
Good afternoon, everybody. My name is Akira Nakagawa of JPNE. 4 of us will continue to talk about the common issue about IPv6 transition. Firstly, I'll talk about MAP-E, and then Motohashi-san will talk about DS Lite, and then Maotari-san will talk about 464X-RAT. And finally, Kashimo-san will talk about, he's from home router maker, and he will talk about home router. Okay, it's my turn, please. Yes, I'll talk about MAP-E. Next, please. Do it by myself? I didn't know. Firstly, I'll introduce you about why we chose MAP-E, and then I'll show you some experiences. I'll skip this. It's the introduction. This is a brief overview of MAP-E. MAP-E is, has basically 2 options, 2 functions. One is IPv4. First one is IPv4 tunnel, and second one is IPv4 sharing, address sharing over IPv6 network. And the tunnel is between home router and this center node. And address sharing is here. But there are some type of address sharing, but we don't have CGN here. We have NAT only here. So it is not double NAT, single NAT here as usual, as before. And there is no logging server here. So it's the brief overview of MAP-E. And it is an entire network of a MAP-E network. I explained 2 of them. And there is, we can do local communication, IPv6 communication and IPv4/v6 communication. The packet doesn't have to go to up here, so it's very efficient. And here, it's the query of the DNS. Query is IPv6 transport. It is the reason why we chose MAP-E. First, 3 points: easy operation and easy customer support, and avoiding traffic from center node. It means local communication. First one, we don't have to take logging at center node, and non-session management at center node. And center node scales according to only traffic. We don't have to see connections, not connection. We don't have to see session at center node. So it's very simple. And easy customer support. Customer doesn't have to configure at home router. It's very important. And I explained at the previous page. Why MAPI for users? Users don't care IPv6, MAPI status. It's like water or air. It's important. Our final goal is a long-range goal, but final goal is before sunset. We are now in step 2. Step 1 is overlaying IPv4 on IPv6 here. We did. And now we are offloading IPv4 traffic to IPv6. And finally, we will remove here IPv4. And we will complete before sunset. I will show you some experiences from our operation. This is the, we tried test at the hotel network, like here, last year. We put here user computer, and we used speed test site on the internet. And we tried testing. The speed was about 800 mega. This is slow. Something wrong, but I didn't change this number. Theoretically, IPv6 is faster than V4 because V4 is the content of V6. But it's the test via internet, so this is just a result. This is the port range for our customer. The MAPI is stateless, so we allocate fixed number of port number to each customer. We allocated here. And before starting our service, we tried over-subscribing test. And this is the result, and this is the port number we allocated. So we believe it's enough. And we had to simplify the V4, V6 troubleshooting. And so we made tools. This is the outline of the test. From this browser of this computer, it sent ping to here, and test 1 is ping here by V4, and test 2 is name resolution, with name resolution, and V6 and V6. And I prepared a demo, but I embedded movie in this PowerPoint, but this is PDF, so I cannot do that. But you can easily guess. If you click here, this screen scrolls up, and the result of the test 1, OK, change OK or NG, and number test 2, OK, OK, OK. This is simple but very convenient test tool. And this is a very big issue. I think it's in the world. The content holder or server have to take ports to find the sender under IPv4 address sharing environment. And it's very hard. So they have to do that. And they have to do another way. They have to reduce the possibility of abuse by offloading traffic to IPv6. By offloading IPv6, it will not go to zero, but the possibility will be reducing. So all of us have to do like that. It's the traffic. The most of the traffic is Google. Most of the V6 traffic is Google. This is the percentage of the V6 of our network. Now, the V6 percentage is about 20%. It is a summary. MAP-E is stable, easy operation, and easy customer support. And speed is fast enough. And effective to use some IPv6 V4 tools to operate dual stack network. And one important thing is to offload traffic to IPv6 for sunsetting IPv4. That's it. Thank you very much.
Any question or comment to Nakagawa-san's presentation? Sunny?
What equipment were you using for your gateway?
Gateway, we don't disclose, sorry. Sorry. We can say the home router.
My problem with MAP-E is that I need to change my gateways. And that's why I can't do it in mobiles.
What problem?
Because for MAP-E you need both ends. And I can't do this because I can't put MAP-E into a mobile device. Because if I do that, then I need to change my gateway to de-encapsulate. And not all vendors support MAP-E today. That's my problem with it at the moment. So I'd love to know what vendor you're using, but that's okay.
In our network, we can design our network is, we can, our final net, we know our final network. So it's easy to assign the port number. We know the number of the users.
Can I answer your question? And have you see the NEC booth on this conference view? Because NEC already published the MAP-E equipment as CPE router. And we have some implementation like ASAMAP, which is open source gateway code, which is developed by the Japanese operator. And we have some implementation on MAP-E. So I will share the information to you.
I'm Masanobu Kawashima from NEC Platforms. I will talk about it later, later presentation. So.
Thank you. Thank you very much, Nakagawa-san. And you're going to introduce the other people?
Next one is Motohashi-san of Multifield.
Thank you very much, Nakagawa-san. I'm Takeshi Motohashi, Internet Multifield. Today, I'd like to show some lessons learned about the CPEs on IPv6 network while deploying with dual stack Lite, DS Lite, in the Japan market. First of all, I'd like to clarify our services. We have Internet Multifield has two services. One is JPNAP, which you may know, one of the major internet exchange service provider in Asia. But we also have the other service, Transix, today's topic. So Transix, what's Transix? We provide IPv6, IP over Ethernet service, access service on NTT East and West, Fred Hikari Next. which is optical fiber access to the all over Japan. Actually, optical fiber network, access network, are provided by NTT, so we are not access service provider. We are virtual network enabler. We started this service, IPv6 IPOE service, 3 years ago, and IPv4 over IPv6 service started since last October. So we chose dual stack write IP for our v4 over v6 service. So we prepare after NAPT router, NAPT equipment on our network, and we also need CPEs for accessing dual stack write NAPT router. So, but currently we are asking end users or ISPs to prepare CPEs using having a DS Lite function. So that's why we need to have investigation about CPEs in the Japan market. First of all, we should prepare CPEs with DS Lite function, and we also have to check, have to examine CPEs with IPv6 network using, because we have our network need to have both type of the IPv6 network environment, the DHCP PD and RA. So not only just checking the function of DS Lite in the CPEs, but also we should take care of these IPv6 network treatment for, in the CPEs. So far, we've examined the 5 typical CPEs in Japan market. So I'd like to share some knowledge or investigation results of this equipment. So we try to first we should check whether CP has DS Lite function. So that's why we chose 5 CPEs so far. And we checked the DHCP PD environment for each CPEs. So at that time, it works. Each of CPE works very well. IPv6 network management and the DS Lite function also works well. So it's okay. So, and one more thing, we have sometimes customers has RA environment from our network. So we also checked it for each CPEs. So DS Lite function, every CPEs works well. So we don't have to see any trouble for using DS Lite. And when it comes to IPv6 network environment for the RA, there are many variety of configuration. So each CPE has its own style of how to adapt this RA situation. For example, IPv6 pass-through is selected by one CPE, ND proxy is selected by another. So when you need to have CPEs for IPv6 network with RA environment, you need to figure out how to manage such kind of network, how to connect to the IPv6 network with such kind of the home router or office routers. And we also thinking about filtering. Because of the security issue, we might think how to connect to the IPv6 network from this CPEs. So typically we need to have some filtering setting for the CPEs. So each CPE has some CPEs has small options for filtering. The others are doing everything, but there are so many type of the filtering settings. So sometimes the customers need to check it for a long time. So if you have you want to provide the security function with filtering for the customers, it would be nice to provide the recommendation for filtering setting or provide managed CPE would be also nice idea to keep security issue. Finally, some CPEs has when we like to set after address setting, some CPE needs to put in with IP address instead of host name. So it would be better to set it up with host name for maintenance of the network. So that's what we learned about the CPEs for adapting our network with IPv6. So we also are interested in the current market or market expansion with DS Lite deployment. So there are several researches on the website, and ISPs in Europe try to provide the DS Lite. A couple of ISPs, and mainly in Germany, there are several ISPs using DS Lite. And in terms of the CPEs, D-Link and the other equipment providers try to provide some of the products on DS Lite function, and OpenWRT is also the nice software to provide the DS Lite module currently. So it will be DS Lite is one of the good option for us because there are many equipment providers, CPE providers in the world. So please share and exchange information if you have something. It is a good idea to share. Thank you very much. Any questions or comment?
I have a question. Motohashi-san, you mentioned about Flex Hikari started IPv4 over IPv6 services in October 2014?
We started.
You started?
We started, yeah.
All right, so it's my hobby to check the APNIC labs.apnic.net data, IPv6 readiness and users ratio. Every now and then I hop in and check it. And I noticed Japan showing about hovering 8% in October, around slightly before October 2014. And after October 2014, suddenly it jumped up to 10%,
Uh-huh.
and it's still growing steadily. Is that the impact of this multi-fields movement?
I think it not, because mainly currently in Japan market, especially for NTT's East and West access line, not only providing the IP over Ethernet service, but also some other ISPs are providing the PPP over Ethernet, PPPoE VLOC service. And some major, some of the major ISPs are now trying to provide PPPoE V6. So I think that both IPoE as well as PPPoE's V6 contribute such kind of numbers.
Thank you very much. Thank you, Mr. Motohashi.
Thank you.
Our next speaker is Mawatari-san. Yes, Mawatari-san. He will talk about IPv4 and IPv6 network in this conference venue.
Hi, good afternoon, everyone. I'm Masaka Mawatari, belongs to Japan Internet Exchange and APRICOT APAN 2015 Network NOC team as well. I'll talk about IPv4 or IPv6 in the venue APRICOT APAN 2015 Fukuoka. Let me start with introduction of this presentation. As you may expect, APRICOT APAN conference network is IPv6 available. And two ways to offer IPv6 offered to attendees. One is dual stack network, SSID APRICOT, APRICOT-G. Another is 464X SSID fitset APRICOT-X. We built 464X in the venue because I believe it can driving further IPv6 deployment forward. And I believe that IPv4 by IPv6 is one of catalysts to deploy IPv6. Let us back to the overview of IPv4 over IPv6 method. There are four methods in this slide. Vertical axis means translation or tunneling. And upper side is translation method, and lower side is tunneling method. And left side is stateless address sharing method, and right side is stateful address sharing method. I'll focus on 464X in this presentation. This is 464X overview. 464X is combination of existing technology, stateless NAT64 RFC 6145, and stateful NAT64 RFC 6146. And stateless NAT64 works in CDAT, which is located in client side. And stateful NAT64 works in PRAT, which is located in provider side. And this method is simple and reasonable. And here is 46X at network the venue overview slide. CLAT is located in conference venue here, and PLAT is located in JPIX data center at Tokyo. This slide shows network inside conference venue. As I talked before, we built CLAT side network inside of venue. We use Cisco ASR1K as a CLAT. This ASR1K installed iOS XE standard edition. We can get everywhere. It's not special edition. Here is statistics for 60X at network. This is traffic volume measured at interfaces of CLAT. This is yesterday's data. As you can see, top peak traffic volume is around 20 megabit per second. And the next is the number of Wi-Fi associations, SSID for XLAT. As you can see, SSID for APRICOT XLAT peak of associations number is over 150 stations. Let me conclude my presentation. Please try APRICOT-XLAT SSID. Thank you for your attention.
Thank you, Mawatari-san. Do you have anyone have any question, comment? Narcel?
Hi, Narcel Ballina Rodriguez from ICSE. I would like to know what actually went wrong, if you had any issue in the deployment or more about your experiences. Thank you.
We don't have any issue about 46 for XLAT network so far. It's no problem.
So Mawatari-san, this 140 to 150 stations using the 464 XLAT SSID, are they 100% mobile devices like this?
Probably around 30% of attendees. All attendees.
All attendees?
Yes.
So the mobile devices?
Yeah, probably half is mobile and half is laptop.
Right, and do you have capability to find out proportion of vendors of those mobile devices and laptop devices who are the makers of those 140 to 150 stations? Can you identify makers?
I didn't talk about that to vendors.
Okay, right. Maybe I'll ask more questions. It's a very interesting presentation.
Can I ask
one question? How many sessions per user or per access? Is there any average numbers or currently you have?
How many sessions?
Sessions for
it
each.
Means mapping
Yes,
entry in PLAT. Probably 2,000.
2,000 total.
About, yes, total.
Oh, okay. Thank you very much.
Thank you, Mawatari-san.
Thank you very much.
Thank you. Next presentation is from Kawashima-san, MEC.
Good evening. I'm Masanobu Kawashima from NEC Platforms. My field of expertise is IPv6. So I'm in charge of IPv6 projects and also Asian country projects. I'd like to talk to you about NEC Platforms IPv6 for IPv6 deployment. This slide shows a summary of IPv6 activity. Please take a look at prototype and product. We've been carrying out IPv6 initiatives since around 2003, and we are certified to use the IPv6 ready logo for small ATM router and also 8-term IPv6 prototype model for consumer. Since then, we've accumulated more than 10 years of expertise, experience and know-how related to IPv6. So after 2009, we were focused on commercial IPv6 service with telecom carriers and also ISPs. At the same time, we've joined the IETF in order to report IPv6 issues from our experience and also propose 464 extract as one of the IPv6 transition technology. As a result, we were able to publish 2 RFC documents. This slide shows IPv6 deployment on the global internet. As you can see, KDDI is SAT and CTC is 13th. We are providing IPv6 CPE to them for their IPv6 deployment. This is a very honorable thing for us. Interestingly, T-Mobile USA has already started to deploy IPv6 service with 464 extra, just for your reference. I'd like to talk about what is next activity. As you already know, CPE is one of the most important domains for IPv6 deployment. So it should be support IPv6 transition technology for long-term strategy and also managing cost reduction. IPv6 transition technology accelerates IPv6 deployment and reduce barriers to IPv6 uptake. So our recent CPE has already supported 464 extract, DS Write, and MAP-E. As 3 speakers already mentioned that IPv6 transition technology is different at each network operator because of their policy. So router vendor have no choice in Japan, just kidding. Then avoiding multiple CPE replace and migrations should be a key goal for any network operator. On the other hand, it's difficult to configure translation technology by end users. So our CPE provides automatic network configuration function. It helps end users to remove configuration difficulty. Based on these points, we focus on IPv6 only network with IPv6 transition technology come to be widely used. As I said previous slide, we should set a goal to IPv6 only network with IPv6 transition technology for long-term strategy. This slide shows the difference between dual stack approach and IPv6 transition approach. As you can see, dual stack approach seems more complicated. So we should avoid multiple CPE replace and complicated technical support for a smooth transition to IPv6. As a result, we can also reduce CapEx and OpEx on it. That's all my presentation. If you are interested in our CPE, please come by our booth tomorrow. We will give you cute monkey Corina, even if you are not interested in our CPE. Don't worry. Thank you for kind attention.
Thank you, Kato-san. Does anyone have question or comment? Right? Well, thank you very much.
Thank you.
We have one more presentation. It came in last minute from Mayan from China. So he works for university in Beijing, BUPT, and also he is, are you representing VII too? Yeah, VII. So please go ahead. Thank you.
Okay, almost good evening. Sorry, I came in the last minute, so I will be in a very quick way. Otherwise, I'll occupy other people's time. Now, is it? How can I turn down next page? Okay, so next page, please. This one, okay. Last year is the 20 years anniversary of CERNET, so we celebrate the V4, but also a lot of activity on IPv6. So the next slide will show you. Most of the links are still very stable and providing very good services. But even for those optical fiber cut or power failure, some other things, total availability is over 99.2, so still a bit high. Then this is the traffic distribution among our member universities. This is my university traffic, so occupies the majority of the traffic because we're providing a lot of IPv6 enabled contents. So TV streamings, educational courseware, a lot of file sharing contents. So this is the traffic distribution. This is the traffic originated by AS. So we have a domestic traffic, but also a lot of overseas traffic. All the data I will not repeat one by one, but you can see really connecting worldwide. A lot of people visiting our service. Also our students, researchers doing different kind of experiment with overseas partners, both to Europe, to North America area, but also other worldwide IPv6 partners. This is the prototype distribution of the traffic. See, we have TCP, UDP, and a lot of other ERE tunnels, a lot of other traffics there. And this is the link from the CERNET to beyond link to Europe. Number unit is in the TB, terabytes, so see a lot of traffic already happen every day. This is the traffic showing the aggregate traffic over the backbone, so something over 40 gigabit aggregate traffic there. This is the aggregate one. This is my university POP. We connecting something 20 universities, some university by using 10 gig link to the backbone and almost getting congested. Then this is the winter vacation, so the traffic got a little bit down. This week, we're starting our new semester, so traffic will still be getting higher. And more other traffics. This is the traffic with Hong Kong node, and then this is the traffic with Internet 2 in the North America higher education institutions, something 4 giga, something every day. This is with the commercial networks, China Net, China Telecom. By this stat data, you can see not much commercial traffic there, less than 1 giga. So commercial deployment still need to improve. This part is delivered by the BI company. This is a private company, and they have a lot of research activities and international collaboration on IPv6 events. So they organize conference, a lot of joint research and on product testings. BUPT, my university, have a joint project with them. So here I would like to report on the current deployment of IPv6 enabled DNS root server experiment. Currently, we have in total 13 root servers worldwide. But you know, people rely on DNS quite intensively, quite much. Without DNS, a lot of applications couldn't run properly. But how to ensure the internet in a more stable services and also get a good performance, and even larger people relying on the security issues. So we're doing this kind of experiment. Show you currently North America area, a lot of root servers, top-level domain distribution in the North America area, but also in Asia, only one root server there, and in Europe there are another 2. Anycast root servers have been distributed, a lot of mirrors worldwide, something over 400 worldwide. But how to extend the service even more secure, even more stable, and have more general services? People rely on internet more and more. So there are a lot of activities to doing research related with the root server extension and the scalability. There are several ways to extend the root server service availability. For example, to increase the capability of the system, more machines, more mirrors, or more deployment, but also how to increase the letters. For example, not only the 13 root server, but also more than 13s. So how can we do that? There are some of the discussions and technical research activities and also the standardization activity happen in the community. So the recent workshop about the DNS future root services have been happened in Hong Kong last year, December 2004. For more information, you are encouraged to read more on this link. And also IEEE, sorry, I should correct this one. It should be IETF, not IEEE. IETF work on root server scaling. There are several draft, RFC draft available. More works related with this one. A lot of effort from Europe, from North America, from Asia, people join in. BI is one of the efforts, and the BUPT join in the effort together. The testbed has been established on the IPv6 DNS root system. So there is experiment environment and root server testbed, IPv6 enabled testbed, and also the letter L root server instances have been established in the test bed. So we can do closely or both openly. So taking the real traffic take interaction with the worldwide root server system. And a lot of technical experts worldwide have been visit the lab. This is the testbed connectivity currently. So we have an IPv6 forum connection with outside and also with the wide project in Japan, and IC in North America, in US, and South California University in North America area. But domestically, we have a CSNet, CERNet, China Unicom, and ZNet, those kind of companies working together to do the test. A parallel root zone operation has been proposed. Left-hand side picture showing the current structure, but the right-hand side picture showing the proposed solutions for scaling the root server. The feasibility already have been proven and be recognized by the visitors. So more work will be happening in the coming months. This is the monitoring screen cut to showing how the performance is currently working. And also the testbed on the IPv6 enabled DNS root system have been established. So more case studies and data analysis, more experiments have been conducted. So it's also open to the community. Everybody would like to see the progress and join the experiment and initiate any kind of test, or welcome to contact us. So as a very brief introduction, I would like to say V6 still going on, but slowly increasing in the commercial networks in China. For academic network, we have a lot of experiment, a lot of research activities, and the daily traffic is going on. And regarding the IPv6 DNS root server testbed, we have a lot of work has been done, and also welcome more collaboration worldwide. Thank you.
Thank you, Professor Maya. Very. It's okay.
That's okay.
Sorry.
Okay, that's okay.
No, go ahead. I thought it's.
No, nothing. That's okay. Any questions? I won't repeat it. I won't read it one by one.
Hi, I've got only one question. How much is VeriSign involved in this?
Currently, technical speaking, IETF process people are involved in, I suppose. Not the experiment yet. Yeah.
Right, thank you. Any question or comment from the floor? You know, APNIC support mirroring of root server implementation. Yeah. So if you have any request, please let me know too. We can support the implementation of mirroring of root server. Okay.
Thank you.
Thank you very much.
Thank you.
Thank you. Thank you very much, Professor. Yeah. Thank you. So we finish all the agenda items. Thank you very much for staying back with us. Next, both IPv6 Readiness Measurement BoF and APIPv6 Task Force co-hosting meeting will be held at APNIC 40 in Jakarta, September. So we are looking forward to having your interesting stories, furthermore progressing IPv6 deployment statistics and anecdotal stories. And one last thing, I'm wearing the APIPv6 Task Force Secretariat hat. I would like to thank you for all APNIC staff and hotel staff staying back with us, enabled IPI remote participation too. So thank you very much, and put hands together for them. Thank you. All right, thank you very much. See you in Jakarta.